Use Web Proxy. The actions DNAT, accept, drop, reject and redirect are manipulating network traffic according to the IP address, or TCP/UDP port number. For Web Proxy, the control is specific to HTTP itself. A proxy receives the requests from the client programs and forwards the requests to the actual server. It also gets the responses from the server and sends those responses to the original client programs. A web proxy can be used to cache the previously loaded data, screen the web links, or control the time slot for web access. Those are the aspects in consideration by using web proxy from the zone LOC to zone net, the internet. However, proxy is with the usage to resolve other problems. Consider the scenario that there are several web hosts for internal use and zone LOC. For people in zone net, how to access those hosts in zone LOC? The access from zone net to zone LOC is blocked by default. However, if people have a way to access the proxy in zone FW, they would the chance to access the web hosts in zone LOC because the connections from zone FW to zone LOC are allowed. And the problem of accessing internal web hosts turns out to be the problem of accessing web proxy in zone FW. We usually use this scheme along with VPN. Using VPN alone might not resolve in the case that some of the web hosts do not have the setting of gateway to the subnet of VPN. The web proxy provided on the base platform is listening the requests on all its network interfaces so that accessing via proxy to the web hosts is just like to access the web host from base platform from the view of the web hosts. It can circumvent some routing table setting issues. There might be some other reasons of using web proxy. For example, some legacy web applications are only accepting the connections from a specific IP address. To open the access of those legacy web applications to larger group of people without modifying the applications, using the web proxy to access the legacy web applications might be a good approach. In the following sections, we introduce how to change some setting of the web proxy provided by the base platform. Web caching. The web proxy is listening on TCP port 3128 by default on the base platform. And it can be changed via border proxy web caching. Illustration 62, screen snapshot for web proxy caching and access. To use web proxy, you need to change the setting on your web browser. If using redirect action from the base platform to redirect port 80 to this proxy port, this is called transparent proxy. And it does need to ask users to change the proxy setting on the web browser. And the networks allowed to access this proxy are set on the right box. Those might be modified to restrict the access. URL screening. If web proxy is used, the list of blocking URLs can be added via border proxy URL screening. Illustration 63, URL screening in web proxy and file uploading via HTML form can also be blocked. However, data in HTTPS cannot be deciphered without the keys associated with certificates, so that file uploading cannot be blocked in HTTPS. You need to block the whole HTTPS traffic. Access block time. The web access via proxy can be blocked during specific time frame. Illustration 64, time slot setting to block HTTP access on web proxy. For example, on the time slot from 8 to 12 o'clock on every Monday, it is forbidden to use HTTP. The field time can be filled as 08:00-12:00 and select M, Monday, on the field weekday. Traffic bandwidth control. To regulate the bandwidth of network traffic, we perform the setting according to the following procedure: set the limit for the physical network interface, classify the traffic of that interface into several groups and set the limit and priority for each group, and then determine the group of the packets according to source, destination, and TCP/UDP port numbers. For example, we limit the inbound and outbound bandwidth of an interface F0 to 100 bits/SEC and classify the traffic into 4 CLASs, class 1, with highest priority, priority 1, the minimum rate is 100 kbits/SEC, and the maximum allowed bandwidth is 180 kbits/SEC, class 2, with second priority, the minimum rate is 1/4 of the total bandwidth of the interface, and the maximum allowed bandwidth is the full bandwidth of the interface, class 3, with third priority, the minimum rate is 1/4 of the total bandwidth, and the maximum allowed bandwidth is the full bandwidth, class 4, with fourth priority, the minimum rate is 1/8 of the total bandwidth, and the maximum allowed bandwidth is 80% of the total. But what kind of traffic should be marked as class 1, class 2, class 3 or class 4? The mark should be made according to some attributes of the network packets, for example, source, destination, and TCP/UDP port number. And if the network packets do not match anything we specify, they will be marked as class 3. This is roughly done for the bandwidth setting for the network traffic. In the following sections, the detailed steps will be introduced at border bandwidth interface limiting, border bandwidth priority classes, and border bandwidth traffic prioritizing. Setting network interface bandwidth. Illustration 65, setting network interface bandwidth. The inbound bandwidth and outbound bandwidth of an Ethernet interface can be regulated via the setting at border bandwidth interface limiting. In the hardware specification of an Ethernet interface, the bandwidth of the interface is usually provided as 1000 MB/s, 100 MB/s, or 10 MB/s. It is a value selected from some given numbers via auto-negotiation. Our setting here is not to touch that value. Instead, the setting here is a control process to determine how many frames we should send or receive from Ethernet interface. For the setting of inbound bandwidth, the network frames have already been received by the Ethernet interface before the base platform processes them. Thus, the only way to regulate the inbound bandwidth is to drop some received packets if it over the limit we specify. Throwing out the received traffic sometimes means the other end needs to send them again. The effective bandwidth for the upper layers of applications might be much lower. The following is an example to set inbound and outbound bandwidth as 100 Mbit/section. Please note that the number needs to be converted in the unit kbit/sec. Illustration 66, setting inbound and outbound bandwidth after pressing Add button, the box on the right will display as. Illustration 67, screen snapshot after setting interface bandwidth. In the meanwhile, 4 priority classes are created automatically. They can be seen via border bandwidth priority classes. Illustration 68, priority classes after setting interface bandwidth limit. You might modify the setting according to your application. In the screen snapshot above, Mark 3 is the default class. No matter how you modify, you should have a default class for the network traffic. Otherwise, the border engine will fail to start up successfully. Define priority classes. Illustration 69, screen snapshot for defining priority classes. As indicated in the previous section, 4 priority classes will be created after the bandwidth of an Ethernet interface is set. And the setting can be modified thereafter. The field mark can be an integer between 1 to 255, the field priority can be an integer in the range 1 to 65,535. The field option can be one of the following: default, to indicate the class of the traffic not marked explicitly, TOS equals 0 italu/0 smask. This is to define a class by selecting IP packets TOS/precedence/diff/sev octet. TOS TOS name. The following TOS names are used to represent some of the TOS values of associated mask. TOS minimize delay 0x10/0x10, TOS maximize throughput 0x08/0x08, TOS maximize reliability 0x04/0x04, TOS minimize cost 0x02/0x02, TOS normal service 0x00/0x1 TCP/AC. This is for all the TCP/AC packets. Packet marking for traffic control. With the priority classes defined earlier, we can specify the detailed content for each priority class. Illustration 70, screen snapshot for traffic prioritizing. For example, if we would like to prioritize site-to-site VPN traffic, assume it is using UDP port 7777, then we can set as follows: mark 1 packet source, 0.0.0.0/0 packet destination, 0.0.0.0/0 protocol, UDP destination port 7777. This means anywhere 0.0.0.0/0 to anywhere 0.0.0.0/0. The traffic of UDP port 7777 will be marked as 1. And in the previous sections that there are 4 priority classes created right after setting the bandwidth of an Ethernet interface. Network packets with mark 1 are with the highest priority. The priority number is 1, with maximal allowed bandwidth 180 kbit/section. Illustration 71, setting mark for traffic priority. Illustration 72, marking rule. Listing traffic prioritizing is used while bandwidth is very limited, so that we would like to prioritize the network traffic in a very congested channel. However, it is not straightforward to define them well. In the example above, the minimum rate for top priority traffic is with 100 kbit/sec to keep minimum connections. And the maximal bandwidth is 180 kbit/sec. That would not be enough for the applications running on top of this site-to-site VPN. However, if the maximum bandwidth is too large, it might occupy too many resources so that the other applications might be choked. Thus, the setting is very much dependent on the usage pattern on your environment. Limiting the usage of the bandwidth usually happens when the system is under abuse, so that it needs to limit the usage from specific area.